Don here in Florida again. Today I got a problem with my cutter grinder machine. Apparently this shaft at the end had gotten bent. I started it up the other day and the machine just walked across the floor here. You can't hear it too much right now, but that hear that? She's just vibrating like a son of a gun. So I got to looking at it, and sure enough, the shaft on this end is bent. More than likely that happened in shipping. It wasn't like that before. Some of those guys that move your stuff for you, they're pretty rough. So what we're going to do is we're going to tear this down and or take it apart and see if we can't manage to straighten that shaft. A little bit up close view of this. This machine here, I turned this into a cutting machine. I took the cast iron guard that was on here and sliced it in half and put a piece of angle on here, and this is just a piece of car rim that's in there as a guard to keep the sparks from flying out. And then on the other side, I didn't have a cast iron piece on this side. It was just a brush, and I changed that over to a Scotch-Brite to try and make this more utilizable for me. So let's go ahead and tear this out real quick. This just screws on, you guys in focus, with 3 number 10s. And I tried to put them subsurface so when I run something across there, it goes smoothly. This is really great for cutting off like bolt heads and small piece of metal, springs, things like that. If you have a piece of tin and you need to cut it into pieces, oh my god, you can take a piece of tin and just run it right through there, nice and straight. Just there we go. I don't know if you can see, but these are all countersunk for the heads, and that's that piece there. Get this all out of the way. So if you can actually see that shaft wobbling up and down, so that's what we need to take out of there. Take this off. Don't want any of this stuff in the way. And this is left-hand thread, so we're going to reverse the drive on that. Get that out of the way. Oh, come on, baby. There we go. And that. And there's a washer in there to keep that centered. So, yeah, we're going to have to take that off and measure it and find out where. I use wing nuts on most of my equipment. It makes it easier to take apart when you need to, especially things like this. There we go. See that? Wing nuts. This stand, by the way, was the quickest stand I've ever built in my life. It was the end plate from my Reliance motor in my lathe when I did the VFD conversion. Piece of hydraulic shaft that actually had a bolt sticking down through the end, which was the exact same size as the the hole in the Reliance motor. So I just stuck that shaft in there, put a nut on there and some washers, bam, socked it up. I found that plate and scrap and just welded it on the top of there. And I only had to drill 1 hole for this, and it made a perfect motor mount. Okay, coming over here onto my fancy bench, we're gonna get this opened up here a little bit. Let's get a reading off of this. That should do it. Alright, let's see what we got here. Whoa! It's from, I don't know if you can. Okay, and it looks like the bend emanates right about from there. So it was actually bent just about. I guess that plate that was on there kept it from bending this far back, so it's from that point forward. Let's see if I can get a reading closer up on there. Yeah, it's going to be out of sight there. Okay, see, right there, it's just fluctuating. There's about 5 thousandths right there. Get in right on the shaft right there. Okay. Yeah, see right there, it's less than 2 right there. So as you come out, you can see the bend is on this side of that point. Yeah, the further you come out, of course, the worse it gets. So that's terrible right there. So let's try to straighten this shaft up as best we can. The best way to do it is to, because you can't heat this shaft. If you heated that shaft, you'd tear up or melt out the varnish on the windings in here once that shaft started heating through. So I don't suggest doing that. Really what we need to do is hold this shaft tight and try to bend it back. I found this collar right here which I can use to put over the shaft and hammer on. It's a little tight. I might have to put that on the boring bar there and open it up just a little bit. I found that just in the junk pile. So we'll use that to put over here. We want to protect those threads when we start hammering. But what I don't want to do is I don't want to hammer on these bearings. So I want to isolate this shaft down here. So let's see what we can do about isolating that shaft. I think what I want to do is probably put a collar around that shaft, lock that collar in, and then hit on it from out here. It would be just too much effort to put it in the press. I think I can just hammer it back. I had a teacher when I was in heavy equipment school who used to put these in a lathe and actually pound on them in the lathe. And my machine shop teacher would have had just a fit if he'd seen me do something like that. So I'll try not to do it the mechanic's way. We'll try to go the machinist's way and isolate this without using machine tools. Take this off first. Came off nice. And I certainly hope nobody has to do what I'm doing now. I mean, I hope everybody has a straight shaft out there. But, you know, there might be somebody. Get a little measurement on this here. 670. I've got a pin here that's also 670. I might be able to use this pin to isolate that. I could probably cut it off and hold it right there. Let me think about this for a second. That would isolate it, wouldn't it? Let's get a reading off of that. Yeah, see, that's not bent. That's true. All the bend is out here. So yeah, I think we should isolate that. Have we got another method to isolate that? I think I might be able to make I had a piece around here somewhere. Might be able to take a piece of aluminum here and drill and split that. Drill and split it and then lock it in the vise. That might be a better method. Let's see if I can find 670. That's an odd one. See if I can find something that'll drill approximate to that size. Let me look for some tools and I'll be right back. The 6700, 6.670 is 17 millimeter. And I thought I was going to get lucky and have a 17 millimeter bit, but as it turns out I didn't. So we're going to have to make our own hole there. I went ahead and put this in the 4-jaw. This is nothing critical. I just eyeballed it. We got to get a 17 millimeter hole in the middle of this thing. So that's about it. So let's go ahead and start off here with a couple of holes. Oh, she's dull. Actually, she needs some more speed. I don't know what I'm thinking here. It's because I'm talking and turning at the same time. There we go. Just like that. Alright. Get that out of the way now. So we're going to turn that out to 17 millimeter. I said that's a 1/2 inch hole. Oh! Yeah, just barely. Let's see what she'll do. That's a little bit better. Oh, right on 17. Beautiful. Okay, so let's get that bad boy out of there. What do I do with my key? Yeah, where'd I put it? It's always nice to have multiples, right? So there we go. 17 millimeter straight through. Let's go check it on the shaft real quick, make sure that she's gonna fit right. Oh yeah, just like that. Now we're gonna go over to the saw. I wonder if I can do this as a one-hand operation. And we're just gonna slot that. Haha, knew I could do it with one hand. And the idea is this piece here is going to go around that shaft and we're going to clamp it in the vise and hopefully isolate that so that we can pound on it upstairs. So I hope it's not too loose. Find out here in a second, won't we? There. I tested to make sure that this would work in the vise, and it does. So let's go ahead and find out where our high spot is on here so we know which side to pound from. So that's our low right there. So low is here. Just gonna make a dot on that. And hopefully our high will be right there. That's the high spot right there. So we'll make a line right here. That's where we need to give her some loving. Okay, so yep, 180 out. So let's go ahead and set her up in the vise. I'll set it up in the vise, and go like that. Okay, so I'm set up in the vise here. This is acting like a collet around the shaft here. We've got our high spot marked right there. The shaft is solid. We're going to take a collar. What do I do with that collar? I'm going to take a collar and put it down over here. That's mainly to protect the threads and shaft when we start pounding on it. So I'm going to use a lead hammer. So we got our collar on there. I'm going to give it a little tap here. You know what? Where's my... Let's just get a reading off of here for shits and giggles. Yeah, you can definitely see there's a bend there, even with this crude aperture. Yeah. So let's go ahead and give her a couple whacks here and see if that helped. It's starting to move. Look at that, the collar's even going down on there nicer now. So we must be taking some of that bend out of there. Yeah, almost there. We're going to take it off and check it on the dial indicator just to find out for sure where we're at. She's getting there. The high spot, which is just a couple of thousandths now, actually migrated off just a little bit. So we're gonna change position here just a little bit and see if we can tap that in too. You know, you put a straight edge on here, I'll tell you what, it looks like it's right there. But when you get on the dial indicator, you know, it's another story. So you gotta be real careful at this point because I'm just down to a couple thousandths. Yeah, all the bend is right up at this end now. See if we can get an angle where we can see that. So right here where the most of the bend was when we started, it's pretty much about a thousandths now, maybe slightly over a thousandths. And out here on the very end, we're looking at about 3 to 4 thousandths. So that's gonna have to be acceptable. Could be here all day chasing that outer 3 thousandths. I mean, it literally by eye now spins ideal. You could literally see it jumping around before. So hopefully when we get it back on there, she's gonna run nice and smooth. So let me see if I got a couple more screws here. Okay, so I'm gonna set that back up here. First hole set up. There we go. Get that on there. Get this back on here. I really love these Scotch-Brite wheels. I really do. I should probably make some kind of centering device for this, better than what I've got here. Alright, let's just do a little test run before we finish putting it back together. Make sure it's running like it's supposed to. way better than it was. I think it's just where it's sitting on. Literally, I walked away from this the other day and it was halfway across the floor, so this is way better than it was. I'm really happy. So let me put that back together. Oh, I set those tools down. Here they are. There's one. And there's this. So, and there she rolls. Look at that. Just like a new one. Take my foot off it, yeah. Before, if I'd taken my foot off it, it would just walk across the floor like this. Crazy, huh? So I think we're going to call that a success story. One last thing I want to talk about here before I finish up. The grinder thing was just tons of fun. Finally got something fixed and finished that I can continue to use in the garage, and I use that all the time. Literally, it's probably one of my top 5 used tools in here. This sander here, this belt sander, it was a Kalamazoo 2x48. It didn't have this guard on here. It was actually a piece of junk. Guy that goes around and collects scrap metal and stuff found it, and all this guard stuff was gone, and it didn't have this part here, the plate. Basically everything was missing. All it had was the shaft back here and the motor, and basically that was it. The plat in here out on me in pieces out of the center, and I just started JB welding them in and filing them down. But it was like every couple months more stuff would come out, and it was like following a pattern around there. So in the end, I just said enough is enough, and I gathered up the pieces the last time it threw, and it threw out all its rubber, about that much of it, and I JB welded it all back into place. And once I had it all JB welded in, there was plenty of JB weld in there, I turned the wheel itself. I cut right into the rubber itself, and about 1/4 of an inch back this way and 1/4 inch this way, and used a piece of 4.5 inch piece of PVC pipe to where it would just start to register the same height as the rubber in the middle here. And I JB welded all that in, and once that was all hardened, I turned it on the lathe. It has to have a profile down here, so I had to profile it. So I got that all profiled out, but I realized when I was putting it back together, this PVC is super slippery, and I was like, Lordy Lord, how's that gonna turn that belt and grab well to turn it? I was a little concerned about that. And then I remembered my son gave me this crap here called Flex Seal. I'm not advertising for these guys. I've never seen this stuff. Well, I was living in Europe for so long, I never had. I'd never seen this stuff before, and when he moved to Boston, he gave me a couple cans of this stuff, and I thought, I wonder if this would rubberize the surface of this. So I had this piece already in the lathe. I took this Flex Seal, covered everything on the lathe so it wouldn't overspray, and just sprayed it as it turned. And I ran maybe 1 coating, 2 coatings around there, and let it harden overnight. Well, I came back the next morning. Let me get you in there a little bit. I came back the next morning, and I got some sandpaper. I thought, I'm going to smooth that out because it's a little bit rough on that rubber there. And I took a piece of sandpaper and I started spinning that. Oh my God, I almost burned my fingers in about 2 seconds. That stuff has so much frictional resistance on it. It's just amazing. I couldn't even touch that with the sandpaper. And I said, holy cow, it's hard. It's sticky. It's got a lot of friction. It's rubberized. And so I threw it back on the machine, and my God, it's worked as good as new. I haven't had any blow-ups or explosions or anything with it. It's run just as fine as wine. Like that. I'm happy as an all can be. So there's got to be some uses around the shop for this Flex Seal. I mean, it's supposed to be for your outdoor stuff, but you know, I don't know. My house is pretty new. I don't have leaks or anything, so I don't worry about that. But for something like that, it was just amazing. I'll probably use it again. As a matter of fact, I'm going to be doing a video project here, building some feet for the Monarch lathe over there, because I want to square it up in the shop. Literally with a 1,300 pound cast iron base, it doesn't need it, but I just want to get it lower to the ground. I want it level, and I use levels on the lathe, so you got to have the lathe level anyway. So I need to get that leveled up, and I think I'm probably going to use these on the bottoms and sides of the feet when I put that together as sort of like a humidity / temperature barrier. I don't know how it will assist with vibration or anything, but as far as a barrier, I think it'll work great. And it is hard. That stuff is just as hard yet tacky in a frictional sense that it worked out perfect for this. So I'm just putting my little spin on the Flex Seal there. Anyway, so I guess that's it for this one. From Florida, Don out.